CMS.
Okay, so let's start. So this is the GATE engineering mathematics syllabus. So you can see, so there are linear algebra, calculus, differential equations, complex variables, probability, statistics, and numerical methods. And this is the table which shows on which topics GATE 2023 has covered. We can see that in the last year there are total 9 questions were asked. Okay, so and the total weightage was 13 marks. So you can see that how important this subject is from the GATE perspective. And the cutoff of the last GATE is 28.4, which means that you are almost near to the GATE cutoff. Okay, so if you clear all marks, if you scored all marks which were asked in the mathematics subject, then you are very close to the cutoff. So we tentatively we will have total 26 weeks. So first to 5 weeks I will discuss about the linear algebra, and 6 to 12 calculus, differential equation, complex variable, probability statistics, and numerical methods. So we can see that most weeks we are giving to the calculus, because calculus is very important from the GATE perspective. You can see that total 6 marks were asked from the calculus only, and here you can see also, so you can also see that 2 marks are also from the calculus, but I am considering these two are different chapter. Okay, so I will suggest this textbook, which is by Kreisig, and the name of that book is Advanced Engineering Mathematics, which is from the Wiley publication. If you are reading this book, then you will have a good perspective from the for the engineering mathematics point of view, and for the GATE also. So okay, let's move to the first class. So the first week, as I told you, I will discuss about the linear algebra. So the first thing I will ask, why it is linear? Okay, so in your GATE we mostly use matrices. Okay, but when you are going towards the more technical, it will call linear algebra. Okay, so why it is linear? Can you tell me? Any guys? Anyone? No. Okay, so let us consider three vectors: u, v, and w. So now tell me, what is linear combination? What is linear combination? Tell me. What is linear combination? Anyone? Response. I need response.
So any combination of u, v, w such that the power of u, v and w is 1.
Yes, it's correct. So which means that any kind of combination of u, v and such, if there are many vectors. So which means that if you write like this, au plus bv plus cw and plus plus plus. So this is called linear combination, where a, b and c, a, b, c are constants. Okay, and u, v, w are vectors. Okay, so any kind of vectors, not only 1D, 2D, 3D, many kind of, you can say. Okay, so which means that u, v, w belongs to set of any kind of n dimensional space. Okay, so this is the combination which is called linear combination. Now if you write if n equal to 3, which means that three dimensional space. Okay, three dimensional space. So linear combination what will be? A times u1 u2 u3, okay, plus b times v1 v2 v3 plus c times w1 w2 w3, okay, plus dot dot dot. Okay, now you can see that we can also write it as follow: a u1 plus b v1 plus c w1 plus dot dot dot. Similarly, a u2 plus b v2 plus c w2 plus dot dot dot. a u3 plus b v3 plus c w3 plus dot dot dot. Okay, now if you can write it as below: u1 v1 w1 dot 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 u2 v2 w2 dot 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 u3 v3 w3 dot dot dot, and like this: a b c dot dot dot. Okay, so any kind of linear combination we can also write it in this form. Okay, where this one is called matrix. Okay, and this one is called vector. Okay, vector is also a form of matrix. Okay, so don't confuse with this. Okay, but any kind of representation, if you see like this, n by 1, okay, so we will call it as a vector. Okay, so let's take an example. Suppose you have two vectors, vector u equal to 1 2 3, okay, a vector v equal to 0 1 3. Okay, now I want to write in the form of linear combination. So what will be it? So a times 1 2 3 plus b times 0 1 3. Okay, that is nothing but au plus bv. Okay, in other words we can also write it as like this: au plus bv. Okay, so now I want to ask, if you see these two vector in space, if you see these two vectors in space, so what kind of presentation we will see? So if we talk about the 1 2 3 vector, suppose this is 1 2 3 vector. Okay, and this is 0 1 3 vector. Okay, so can you tell me, if I want to find linear combinations such that I want to get a vector 2 5 9, so what kind of combination we will need? Tell me. First tell me one question: if I want to write linear combination of these two vectors, which means that au plus bv, will this combination definitely will produce a vector. Okay, definitely it will produce a vector D. Will this vector be in this plane or out of the plane? Tell me.
So it seems like both, like inside and outside, like.
No, I am saying that these two vectors, definitely any kind of two vectors, if you represent, those will always be in a plane. Any kind of two vectors, any kind of two vectors, those always be in a plane. Okay. So now I want to ask, if you write in the linear combination of such that AU plus BV, can you tell me the resulting vector D, will that be D vector in this plane or out of the plane? Did you get it, my
Out.
question?
Yeah, it should be outside of the plane.
No. Okay. So always, 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 when you write two vectors such that linear combination of these two vectors, only two vectors, I'm talking about only two vectors here. Okay, not three vectors. Any kind of two vectors, if you write in a linear combination, the resulting vector will always be in the plane. Okay, suppose I want to write two times of u, I mean 1 2 3 plus 1 times 0 1 3, the resulting vector will be what? 2 5 9. You can see that the linear combination of these two vectors, any kind of combination, if you write, always the producing vector will always be in the plane, any kind of. Okay, so that is called spanning the space. Spanning the space. Got it?
So what is the meaning of spanning?
Spanning the space means it will full cover, it will cover whole two-dimensional space. Here it is not two-dimensional since we are taking these two vectors in the plane, but definitely these vectors are in 3D. But I told you that if you take any kind of two vectors, always those two vectors will be in a plane. Okay, so when you take linear combination, any kind of linear combination, the resulting D vector will always lie in the plane, which means that when you vary the value of A and B, any kind of variation you will do, the resulting vector will always be lying in the plane, which means that any kind of value you put A and B, so those vectors, which means that those vectors are spanning the space, which means that when you write the value of A something, B something, those vectors like this. Okay, so which means that it will cover full this plane. Okay, so which means that any combination of these two vectors is called spanning the space, which means that now I'll take it as an example of 3D. Suppose I'm taking 3D. Okay, so suppose I'm taking one vector 1 0 0. Okay, 1 0 0. Second vector, suppose, see, x-axis, y-axis and z-axis. Suppose I am taking second vector is 0 1 0 and third vector is what? 0 0 1. Okay, so you can see that any kind of vector 2 3 5, we can write it as a linear combination of these three vectors. Which means that what? These three vectors E1 1 0 0, E2 0 1 0, E3 0 0 1 are spanning the three-dimensional space, spanning the 3D, whole 3D space. Are you getting my point? Tell me. Is it fine now?
Yes, sir.
Yeah.
Sir, linear combination, not understand.
Yeah, what?
Sir, what is linear combination, sir? I don't understand.
I told you, na, linear combination, which means that when you write any kind, I mean, if you have some vectors, then if you write like this in the linear form, means AU, BV, CW, where VW, VU, W are vectors and A, V, C are constants. When you write in this form is called linear combination.
In combination.
Okay?
Okay, sir.
Remember, A, B, C are A, B, C, D, whatever. These are constants, but V, U, W are vectors. So, which means that when you write any combination, when you write any combination of those two vectors, so the resulting vectors or all linear combination will always span that space. Here you can see that we are taking just two vectors, which means that when you do the any kind of linear combination, that resulting vector will always be in this plane. Okay, will always be in this plane. Here I am taking three kind of vectors. Those are 0, 0, 1, 1, 0, 0, 0, 1, 0. So you can see that these three vectors are spanning whole 3D space. I mean, any kind of vectors you bring, I can write in this form: A, U plus BV plus CW, which means that these three vectors are spanning whole 3D space. Okay, got it?
Yes, sir.
Yeah. Now let's move forward. Now I want to find A and B such that AU plus BV will result into W, where W equal to 259. Okay, and U is same as earlier. I told you 1, 2, 3. V is 0, 1, 3. Tell me, what will be the value of A and B? I want to write U and V of linear combination such that it will result W. Now I want to find the value of A and B. What will be those?
A equals 2 and B equals 1.
1. Good. Because I just discussed, okay? I just discussed. You can see. Now I want to change W. If W equal to not 259 but it is 2510. Now tell me what will be the value of A and B. If you write your answer in the chat box, definitely I will not look into it. Okay, so just please tell me verbally. Is there any solution?
No, sir.
Why? Can someone answer it? Why? Why? Why it happened? Earlier I told you any kind of combination of these two will result into a vector that will be in that plane. But what happened to this vector? Why you are not getting the value of A and B?
It is not in this plane, sir.
Yes.
It is not in U and V plane.
Yes, because any kind of combination of U and V will always lie in that plane that is spanning by these two vectors. Now here the situation is different. Here what happened? Here what happened when you write u here, v here, then w is actually out of the plane. Okay, so you will not get any value of a and b, because when you write any combination of a and b, even if you find, I mean by hit and trial, if you get a and b, you will not get any solution. You will not get vector w, because w is out of the plane. Okay, so how we will solve it? Now I want to ask, how will I get, what kind of combination if I write, then I can get the w? Tell me. Still I want to get the solution. The answer is you need one more vector. You need one more vector which are not spanning, which are not a part of, or you are which are not, yeah, which are not a part of spanning the space by u and v. Are you getting my point? Tell me.
Sir, W is like resultant of these two vectors?
W, no. I have written W is this 2, 5, 10. You will not get any solution. I have just changed, you know what? I have just incremented this 9 to 1. I know that if you change any one digit by one digit, definitely that will go above the plane. Okay, that's why you are not getting the solution, because any kind of linear combination of these two vectors always lie in this plane. Now I showed you that 2, 5, 9 will actually lie in this plane. That's why you got the solution. Okay, but I've just changed 9 to 10, that I know that will be out of the plane. That's why you are not getting the solution. Did you get it?
Sir, how we know that, sir?
See, here what I did is, when you write 2 times of this vector, okay, and 1 times of this vector will result this vector, because you can see that when you write the 2 times of this and 1 times of this, we will get this vector 2, 5, 9. I have just incremented 9 to 10. That is completely different than 2 times of this and 1 times of this, because you have just incremented that 9 to 1. That will definitely not the part of this plane. That's why you are not getting the solution. Okay, let's understand in another way. Suppose what I did, a times 1, 2, 3, okay, b times 0, 1, 3 equal to, what did I write? 2, 5, 9. Okay, what I can write? I can write a here, 2a plus b here, 3a plus 3b equal to what? 2, 5, 9. Okay, now here what you are getting? A equal to 2. These two equations are sufficient. You don't need to solve this. Here a equal to 2, 2a plus b equal to 5, which means that when you substitute a equal to 2, you will get b equal to 1. You can see that when you substitute a equal to 2 and b equal to 1, it will definitely satisfy this equation. Okay, now what did I just changed to 9 to 10. Will it satisfy? No. Are you getting my point? Because from these two equations, what you are getting? A equal to 2 and B equal to 1. Okay. Now solve this equation. You can see that when you put A equal to 2, B equal to 1, you will get 9, not 10. Which means that it is contradicting. Even if you solve these two, you will not get satisfied by this equation. So each and every time when you solve two equations, the third equation will not satisfy, which means that there is no solution. Okay? Any doubt? The main reason is, I told you, any kind of combination will always lie in that plane, and here the third vector is actually out of the plane. That's why you are not getting the solution. Okay? Tell me. Now we will move forward. We showed that when you write any kind of linear combination, we are actually getting this kind of matrix: u1, v1, w1, dot dot dot, u2, v2, w2, dot dot dot, u3, u3, v3, w3, and a, b, c, dot dot dot, equal to something like t1, t2, t3, dot dot dot. So which means that the whole point of discussion is around this kind of representation. The whole kind of discussion will around this equation. Okay? Now, can you tell me one thing? Can you tell me very familiar 3D set of vectors which always span the whole 3D space? Tell me. Tell me. I just told you, na? These three are vectors. You already know. So any kind of 3D vectors you bring, you can write as the linear combination of these three. Okay? Now we will move forward. So when we move further, then we will get to know these four things. First thing is column space, which is nothing but all linear combination of column vectors. Okay. Second, you will get to know row space, which is nothing but linear combination of all rows. Okay. And third, you will get to know the rank, which is nothing but the number of independent columns or rows. Okay. And fourth, you will get to know elimination or Gauss elimination. Okay. Now tell me, what did you read during your high school to solve linear equations? In high school. First, suppose you have to solve this equation 1x plus 2y equal to 3, 4x plus 5y equal to 6, which means that two equations and two variables. Okay, so in this case, what do you do? First, we know that method of
Substitution or elimination.
substitution, elimination, whatever. Okay, so the very famous is elimination. Okay, elimination. What do you do in the elimination? First, I will eliminate any variable like x or y, something, any. So what will you do? 4 times of equation 1 minus equation 2.
Sir,
Yeah,
what is the point number 4?
Gauss elimination.
Okay.
So in this case you can see that 4x plus 8y equal to 12, 4x plus 5y equal to 6. So you will get 3y
minus
equal
1
to
comma 2, sir.
what?
Minus 1 comma 2, x equal to minus 1, y equal to 2.
Yeah, okay, you are giving the solution. Okay, so now back substitute y into any, into 1 or 2. So you will get x equal to 1. Okay, not x equal to 1, x equal to minus 1, right? Now the second method, we know that Cramer's rule. Cramer's rule. What we will do is, suppose you have something like this, ax plus by equal to c, a1, I am writing a1, b1 equal to c1, and e2 x plus b2y equal to c2. Then from the Cramer's rule, it will tell when you are finding the solution for x, then you have to substitute at the place of constant a1 and a2, we have to substitute c1 and c2, and you will write as it is, and in the denominator you will find the determinant of this. Okay, now for y, what we will do? At the place of coefficient for y, we have to just replace by c1 and c2. And below, the same determinant will appear. Okay, same thing will happen to in three equations. Okay, so now here you can see that if you solve, then x equal to what? 12, 8, no, yeah, 3 to 6, 5, 3 to 6, 5, 3 to 6, 5 divided by determinant 1 to 4, 5. Tell me what is the answer? You will get minus 1. Okay, and for y similarly you can write
2.
1, 3, 4, 6 divided by 1, 2, 4, 5, and you will get the same answer, y equal to 2. So this is the Cramer's rule. Okay, now we will move forward the geometry of the linear equation. Any doubt here?
No, sir.
Okay, now we will move forward to geometry of the linear equations. Okay, so When you solve any kind of linear equation, there will be two kind of geometry. First is called row picture, and second is called column picture. From this kind of perspective, you can solve the linear equations. 1 minute. Okay, so let's take one example for a row picture. Okay, so let's take an equation 2x minus y equal to 1, x plus y equal to 5. So from the row picture method, what we will do is we will look these two equations which are in rows. Okay, so first equation is what 2x minus y equal to 1, which is nothing but equation of straight line. Okay, so what we will do, and second equation is what x plus y equal to 5, which is also equation of straight line. Now we will draw a straight line. Okay, so you can see that for this equation, what will be the intercept, x intercept? What will be x intercept for this equation? Tell me. If you have
1 by 2.
Yes, if you have equation like this, ax plus by equal to c, then you can write it as x divided by c by a plus y divided by c by b equal to 1. So c by a means that x intercept will be nothing but c by a comma 0. Similarly, y intercept will be what? 0 comma c by p. So here you can see that the value of a in this case is nothing but 1 by 2. So here you will take 1 by 2, and y intercept is what? Just minus 1. Okay, so here it is minus 1. Okay, so this equation is what? 2x minus y equal to 1. And the second equation, similarly, you can see that the x intercept is 5 and y intercept is also 5. So here 5. I am not writing up to the scale, but you can imagine. Here 5 means 5 comma 0, and similarly 5 comma 0. Now draw this. Okay, so the intersection of these two lines will be what? The solution, which is nothing but 2 comma 3. So this is called row picture. Okay, so this thing you already know. Now what I'll tell you is column picture. Column picture. From this method also you can solve equations. How? You can see that these two equations you can also write it in this form. X vector 2 comma 1 plus y vector minus 1 comma 1 equal to what? 1 comma 5. Okay. Now what will I do is I will draw these two vectors. Okay, so the first vector has 2 comma 1, which means that 2 comma 1. So this is the first vector. This is what? 2 comma 1. Now the second vector is minus 1 comma 1, which is nothing but, if this intercept is 2, this one, then which means that minus 1 comma 1, which is nothing but this. Okay, this vector is what? Minus 1 comma 1. Now I want to find x and y such that I will get the vector 1 comma 5. Okay, then I know that it is difficult to demonstrate it, but you know, this is also a kind of representation. Suppose you made 2 times of this vector, then what will happen? Tell me. When you want to get 2 times of this vector will just scaled up by 2 times. Okay, are you getting my point? Scaled up by 2 times, then this vector will become what? 4 comma 1. Okay, and when you scaled up this vector by just 1 time, not 1 time, what did you get? Yeah, 3 times, right? So 3 times. So what will you do is just scaled up. Direction will remain same. You know that any kind of vector, when you scale it, the direction remains same, but the magnitude will be different. Okay, so magnitude will be scaled by this. So if you write 3 times of this vector, okay, so 3 times means what? Minus 3 comma 3. Okay, now find the resultant of these 2 vectors. So what will be the resultant? When you draw a parallelogram, then this will be 1 comma 5, 1 5, which means that what? You have to do 2 times of this vector and 3 times of this vector. The resultant will be exactly this. And you can also see that this vector will always remain in this plane. Okay, so this is called column picture.
Sir,
Yeah, tell me.
sir, would it be in same space or like some like different space?
Yeah, what kind of a space you are saying?
Uh, uh, it would be more specific that whether it would be on same coordinate or different coordinate.
It will remain in the same plane, na? Because 2 1 is always will remain in this 2D plane. This one is always will remain in this 2D plane, and you write any kind of combination, the resulting vector will always remain in this plane only. This is 2D, okay, not 3D.
Okay.
Okay, so this is called what? Column picture.
Sir, it would be 4 and 2.
4 and 2. How? When you make it 4 times, 8 and minus 2, that will give 6. So how?
No. When we multiply it by 2, then the new vector will be 4 and 2.
Okay, let's check it. 2 times. 2 times will what? 4. Yeah, this will 2 times, right? Okay. Okay, fine.
Yes, sir.
Yeah.
So,
Yeah.
when you have plotted the vector 1, actually the x and y is taken as the 2 and 1 is actually part of the x, isn't it? Then how can we plot the um,
I'm
y
not getting your question.
sir, actually for the x vector, the vector near the
Here
will
x
be-
is not a vector. Here x and y are just constants, because you are just scaling up, okay, 2 times, which means that here x equal to 2, which means that the solution is x equal to 2 and y equal to 3, and here it is 3 times.
actually, what my doubt is how you plot that position vector. I mean, 2 and 1.
Okay.
By taking 2 as x and 1 as y. I'm confused with we are having another x and y variable. Then how can we take that 2 and 1 as another x and y?
I'm not getting your question. Can someone explain me what he is talking about?
Here the x and y is actually constants.
Yes. Small x and y. Yes.
The new x and y is actually 2 and 1.
No, 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 not new. I want to just want to find what is the value of x and y. And we got it as when you scale this, which means that when you put the value of x is 2. Scaled means what? When you put x equal to 2, which means that you are scaling this vector by 2 times. That's why it becomes 4, 2, right? And when you're scaling this vector by 3 times, it will become what? Minus 3, 3. Okay, now from the vector parallelogram law from the vector, then you can show that when you make parallelogram by using these two vectors, then this diagonal will be the resultant, right? That resultant
Yes.
will nothing but this vector.
Sir,
So
Yeah.
if 2 1 is a eigenvector, then x is the eigenvalue.
No, no, no. Why eigenvector? 2, 1 minus 1, 1 is just a vector, not eigenvector. Vector means anything if you write in this form, n cross 1, we call it as a vector, not eigenvector. I am not talking about here any kind of eigenvector, eigenvalues. We will discuss it later. Okay?
Okay, sir.
Okay, I am
So
not
in
talking about
the
eigenvector. These two things are just a vector.
actually in the raw picture, the x and y is actually variable, and here it's actually becoming constant.
No, no, no.
You don't need to
No, no.
compare.
Here x and y also variable. Constant. I am saying that these two are not vector. Okay, these two are not vector. Here I want to find what will be the value of x and y. Okay.
This 2 and 1 is actually we are taking it as one axis and other one as another one axis.
Here,
I mean,
if you want to write, suppose if you
if
have
we
a
are
vector,
having a vector, then how can we plot that? I mean, how can we select the axis?
suppose if you want to draw a vector 2 comma 1, what does it mean? Which means that you will move along x axis by 2 unit. Okay, 2 unit, and y along 1 unit. Okay, now draw by connecting tail and head. This will call 2 comma 1, because this is the 2 unit, this is 1 unit. Okay, so this is called 2 comma 1 vector. Similarly, when you want to draw minus 1 comma 1, which means that in negative direction you have to go 1 unit. Okay, and vertically you have to go 1 along y axis, which means that this vector is called minus 1 comma 1. Okay, so this is called, this vector is minus 1 comma 1, and this vector is called 2 comma 1. Okay, I am just representing that you have to move 2 unit, which means that you have to move here. 2 means you have to move 2 units along x axis, and this one which means that you have to move 1 unit along y axis. Okay, so which means that this is just a vector. Okay, now I want to write here when you move along, I mean when you do 2 times of this vector, 2 times means what? 4 comma 2, which means that you have to move 4 comma 2, which is nothing but it is just scaling by 2 times. This vector is called what? 4 comma 2. And when you do 3 times of this, which means that minus 3 comma 3, which means that minus 3 times this and 3 times this. So this is nothing but you are just scaling this vector by 3 times. And when you do the resultant of this vector and this vector, you will get what? This vector, which is nothing but 5 comma 3, right? No, 1 comma 5. 1 comma 5. Now it's clear?
Yes, sir. So for the first case, we can't represent it in the vector form. I mean the row method. Actually, the vector can be represented in both column
This is
and
not a vector. These two are not vectors. I'm just showing that you can write these two equations into two forms. If you have two equations such that, I mean like this, 2x minus y equal to 1, x plus y equal to 1, which means that you have two equations. So the solution will be the intersecting point of these two lines. Okay, this is one way. This is called row picture. And also if you want to find the solution, then you have to do what? You have to write these two equations in this form. Okay, now if you draw these two vectors like this, and when you do 2 times of this and 3 times of this vector, then you will get this, which means that what? This vector is nothing but the resultant of these two when you put x equal to 2 and y equal to 3. So that it called, we call it column picture, because you are just representing these two equations in the form of columns. Getting my point?
okay, sir.
Any doubt?
No, sir.
Okay. Now let's move to the 3D space. Suppose example number 2. Okay. Suppose you have equation 2u plus v plus w equal to 5, 4u minus 6v equal to minus 2, minus 2u plus 7v plus 2w equal to 9. In this case also you can solve this equation by row picture and column picture. Okay, so you can see that these three equations are nothing but equation of plane. Okay, so if you write any kind of equation of plane, equation of plane is always be like this: ax plus by plus cz equal to d. Okay, so you can see that these three equations are what? Equation of planes. Okay, so which means that in three-dimensional space, when you draw these three planes, then the intersection of these three planes will be a solution. Okay, now first if you want to write, what will be the x intercept of this plane? Tell me. What will be
5
the
by 2.
5 by 2.
5 by 2. Okay, so here I will write, I will take x axis here, y axis here, and z axis here. Yeah, good. So here it will be 5 by 2, and y intercept will be what? 5, and z intercept will be also 5. Okay, so if you draw this plane, then it will look like this. Okay, so which means that this plane has these three intercept. This one is what? P1 plane. Now I want to draw P2 plane, this one. What will be the x intercept?
1 by minus 1 by 2.
Minus 1 by 2.
Yes. So this plane will be look like this. So this will be P2 plane. You can see that any kind of two planes, when those planes will intersect, then it will form a line. It will form a line. Any kind of plane, when those two planes intersect, it will form a line. Okay, now when you draw the third plane, then it will be difficult to present. Then I will definitely tell you, suppose the intersection point, intersection of these two planes will be like this. Okay, and when you draw this plane, and if the intersection of these two planes will be like this, it is difficult to represent, but definitely when you draw this plane, then definitely the intersection of these two planes will be something like this, which means that the intersection point will be what? Solution. It will be what? Solution. And this is nothing but u equal to, you will get it 1 1 comma w is what? Yeah, 2. Are you getting my point, what I am trying to say? Tell me. I'm trying to say any kind of planes, when those will intersect, it will always form a line. Okay, suppose the intersection of these two will be line 1. Okay, and the intersection of these two will be line 2, which means that the intersection of these two lines will be a what? Point. Okay, so that point will be called what? Solution. So this is called what? Row picture. Okay, sometimes it is very difficult to show on the graph. Okay, now you can see that it will not be always the case that L1 and L2 will always intersect. Suppose that if you have something like this, suppose one line will be like this. Okay, the intersection of first two plane will be like this, and intersection of second and third will be like this, which means that these two lines will never intersect. Then this situation will call what? No solution. And suppose in some situation intersection of one plane will be like this, and intersection of 1 and 2 plane will be like this, and intersection of second and third will be also like this. Then what will be the situation of this? What kind of solution you will get it?
Infinite solution.
Infinite solution. And in this situation you will get what? Unique solution. Are you getting my point? Which means that now I am trying to move forward. Suppose what did I do? The first equation was what? 2u plus v plus w equal to 5. Okay. The second equation was what? 4u minus 6v equal to minus 2. And third one was what? Minus 2u plus 7v plus 2w equal to 9. Now I want to eliminate u in these two equations. After eliminating, what you will get? Tell me just quickly. After eliminating u, what will you get in these two equations? Tell me. You will get it 4v plus w equal to 6. Okay. Now I want to eliminate same u but from these two equations. Then what you will get? You will get 2v plus w equal to 4. Then you can clearly see that these two are nothing but two lines but in the plane of v and w. And these two, you can see that it will definitely, these two are neither parallel what nor superimposed to each other, which means that these two lines will definitely intersect at some point. That's why you are getting unique solution.
Sir, if there are two planes intersecting each other,
Mhm.
then they will intersect throughout the plane. How we can define that the plane will be going through the other plane through a point?
Please repeat your question.
I'm saying that if there are two planes,
Hmm.
if they are intersecting in each other,
Hmm.
they will intersect throughout the plane.
Not throughout the, suppose when two planes will intersect, then definitely they will form a line. If you can imagine, suppose you can imagine in your mind that any kind of plane will intersect, they that will form a line, not a plane always. Imagine, they will always form a line.
Okay, sir.
Yeah, you can imagine. Okay, so you can see that these two equations are neither parallel, okay, nor superimposing to each other, which means that you will get unique solution. You can see that here x intercept is 4, y no, not 4, 3 by 2, 3 by 2, this will be 6, so this line will be like this, and this will be what, 2 comma 4, 2 will be here, 4 will be here. So this is the solution. Okay.
So if we take the first one and second one, actually we'll be getting a third line, isn't it?
Yeah, definitely you will get it third line. But it is sure that the resulting two lines will always be intersecting at a point. They will never superimpose. That's why you are getting a unique solution.
If you take any combination, we will be getting the same two lines.
No, 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 not two line, not always. Not always. Suppose you are eliminating V, you will get some different line. That will be function of U and W. And when you eliminate V from these two, you will get a function of U and W. And those two lines will be different. Because what here you are doing, when you solve these three equations, you have to multiply something by this. You are multiplying 2 times of this and subtracting 2. That's why you are getting equation this, which means that what, those two lines are not, those two planes are not exactly this plane. Are you getting my point? Because when you multiply this plane by 2 times, which means that what, that plane will be different. Are you getting my point?
Okay, sir. So if we take another combination, then but the intersection point will be the same.
Same. You will get unique solution for sure.
Okay.
Okay. Now I will demonstrate it like this. Suppose when you, what did you do? First I will leave first equation as it is. 2u v plus w means 2u plus v plus w, and here what did you do? 0 u, or leave it as it is. 4v plus w, and here what did you get? 2u 2v 2v plus w, 5 6 and 4. Okay. Now if you want to get solution, then what will you do? You will eliminate v. Okay, you will eliminate v, and you cannot eliminate v if these two are non-parallel. You cannot eliminate v if these two are non-parallel. which means that these two equation has to intersect at certain point. That's why you are getting solution. Okay, we will move further, then we will get to know what is the condition of unique solution, multiple solution, okay, no solution. But here you will have some ideas how we are getting unique solution, of how we are getting multiple solutions, right?
So can you explain that last point, that
Here what did you do here? First I will leave this equation as it is. Okay, now from this equation I subtracted 2 times of this equation, then we have written this, right? Okay,
is
and what did you do in this case? We made 2 times of this and subtracted this, then we got this. Now you have to find V and W, and you will not get V and W when these two lines are parallel to each other. Okay, suppose at the place of 4 it is, suppose 2V plus V plus W equal to 5, 4V plus W equal to suppose 6, and suppose 2V plus W equal to something like 6. I mean these two are same. Then what would happen? These two lines are parallel, superimposing to each other, which means that we will have multiple solution. And suppose at the place of 4 it is 10. No, at the place of 4, no, I am writing something else. Suppose at the place of 4 is it as it is, and the third equation is something like this, 4V plus W, but 6 and 4 are different. Then what will happen? First, the second line is this and third line is this. These two will never intersect, which means that what? No solution. Are you getting my point?
yes, sir.
Any doubt here?
No, sir.
Okay. Now we will move further for the column picture. Okay, so sometimes column picture is very handy. It seems like it is difficult, but sometimes it is very handy, because suppose you have something like this, AU plus BV, A1 V1 C1 W1, something more, and A2U plus B2V plus C2W plus dot 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 equal to D2. Then you can see that you can write something like A1 A2, B1 B2, C1 C2. Are you getting my point? What I am trying to say? Suppose you have just two equations, but those two equations are hyperplane. It has more than 3 variables, which means that these two are hyperplane. Very difficult to imagine. Then how will you find the point of intersection of these two planes? It's very difficult. Then what will you do is, you will draw this vector something like this vector something like this vector something like this. All those vectors will lie always in the plane, because these vectors are two dimensional. Okay, so it is sometimes it is easy if you make suppose C times of A1, C times of this, D times of this, then you can get this. But imagining by hyperplane, it is very difficult. So sometimes column picture is very handy, but I am not discussing here. I am discussing column picture for these 3 equations. Okay, so the above equation in the column picture, how can I write? Tell me. in column form. Tell me, what will be the entries?
2, 4 minus 2.
2, 4 minus 2.
1 minus 6, 7.
7, good. And here? 1,
0,
0,
2.
2. And here what will be? 5 minus 2, 9. Okay? Now draw three-dimensional picture. Okay? Suppose it is x-axis, y-axis and z-axis. Now you have to draw 2, 4 minus 2. So x will have 2 unit, y will have 4 unit and z will have minus 2 unit. It will go downward. So this will be what? 2, 4 minus 2. Okay. Now x will be what? 1 unit. So here 1 unit. Y will be minus 6 unit. Minus 6 will be something like this and z will be 7 unit, which means that this will be this vector. 1 minus 6, 7. Similarly, x will be 1 unit, y will be 0 and w will be z unit. So you will get where? Tell me. X will be 1, y will be similarly 0 and z will be there. So you will get something like this. So this will vector will what? 1, 0, 2. Now it's difficult, little bit difficult to imagine, but when you multiply, I mean when you put u equal to what? 1, which means that you are just scaling u as like this, and v equal to what? V equal to what? 1. Okay, and w equal to what? Tell me here. Say something, man. 2 times. So which means that u is just like this, v is like this, and w will be like this. Okay, then the resultant, suppose the resultant of these two vectors u plus v will be something like this. It's very difficult to imagine. So this will be what? 2 times of, I mean u plus v vector. Okay, this is the u plus v vector, and 2 times of w, which means that we have to scale up by this vector. So the resultant will be like this. So this vector is what? U plus v plus 2w. That is nothing but equal to 5 minus 2 comma 9. Okay, so this is the column picture. Column picture. Not so important, so don't worry about it. But I am just showing the representation, how we usually get the solution. Okay. So what we understood till now? We understood that if you have linear combination like this, AU plus BV plus CW equal to D. Okay, suppose you have linear combination of UVW equal to D. Okay, here D is a vector. Here D is what? D is a vector. Okay, A, B, C are constants. So I want to get a vector D by using the linear combination of U, V and W. Then if you have a vector like this, U here, V here, W is out of the plane, and D is here. Will we get the unique solution in this case? Tell me.
No.
What?
No, sir.
You will not get a unique solution.
Yes.
Why? You will get if U, V and W are in three-dimensional space, then you will get definitely a unique solution. Because U and V are in the plane and W is out of the plane, which means that linear combination of U, V, W will cover whole three-dimensional space, and D is out of the plane, which means that you will get A, B and C, because it is covering whole three-dimensional space. Are you getting my point? Here, suppose I have U, V, W, which are element of three-dimensional space, and U, V, W are such that U and V are in the plane and W is out of the plane. It is not necessary that it is a perpendicular, but definitely it is out of the plane. Now there is a vector D that is also out of the plane. Now I want to know the value of A, B and C such that the linear combination of these three vectors will produce a vector D. Will we get a solution for A, B and C? Definitely you will get it, because these three vectors are actually covering the whole three-dimensional space, because the linear combination of U and V will be in the plane. Okay, now the W is out of the plane, which means that the linear combination of these three will cover the whole three-dimensional space, which means that then you will get definitely A, B and C such that the linear combination will be D. Now take this case. U is something like this, V is something like this, and W is like this. Now the vector D is like this. Now you will get the solution.
No, sir.
No solution. Because these three vectors will not span the whole three-dimensional space, because any kind of linear combination of these three will remain in this plane. Then how that will come outward of the plane to get D? That's why you're not getting the solution. Now I will have the third case. U is something like this, V is something like this, W is something like this, and vector D is like this. You will get the solution. Tell me.
Yes.
How many? You will get multiple solution in this case. Is there any problem here?
No, sir.
It's clear or not?
Clear.
Yeah, okay, so today's session is over. Yes, from the next section we will talk about the nature of solutions. Here all kind of nature of solution has been represented by the pictures, so that you can imagine in your mind also. Okay?
Sir, can you share this PPT, sir?
Yeah, sure. I will share my YouTube channel link, okay? So wait 1 minute. So there I will also upload my video lectures. First I will stop